Hey everyone! In this video, we're going to continue looking at this tennis court problem and work on problem 70 from our week 2's assignment. Now, if you worked out the problems from the last video and you used where I placed Karina, then you should have ended up with a value of A as 9.45 feet. Our answer for B ended up being 23.03 feet. And our answer for this distance here of C was 42.77. Okay, so I'm just going to go ahead and put those numbers back on to our original drawing here. I now know that the distance between where the ball lands and the net, that is our value for B. Well, that is now 23.03. And that the value from the net to where the ball is served, which was our C value, that is going to be 42.77. Okay, and so that was from the bird's eye view, right? We were looking at this as if we were up as a bird, looking down on the court. How was this ball being served? For part 70, we now want to start looking at this from the side view. So imagine that you're sitting on the side, maybe in the bleachers, and you're watching Karina serve this ball, and we want to now start to figure out how high does she need to serve that ball? How high does that ball need to be hit? Okay, well, I want you to see that from the side view here, we're going to be creating another set of triangles that can help us out. Okay, now imagine that you're looking at it from the side. Okay, so if I'm looking at it from the side, I want to see the distance from where I'm serving the ball on the ground to how high the ball goes. And that would be one of the sides of my triangles, right? That's how high the ball needs to be served. Now that ball is starting here from being served and it lands down here where the blue dot was. So I'm going to go ahead and redraw this line. This is the line that we already had drawn. This was this line here. And that is the distance that it travels across the court. And the final side of the triangle that I need to draw is how the ball is actually moving. If you watched her serve the ball and hit it, the ball would start up here and it would work its way down to this blue dot there. So hopefully we can see that we just created a right triangle. And I'm going to go ahead and I'm going to redraw that right triangle off to the side right here. Okay, this is my right triangle where this is where the ball is being served, this is where the ball is going to land, and this is the ball up in the air. Now, the whole point of this problem is Karina is serving the ball and she wants it to go over the net. Okay, well the net is 3 feet tall. So we need this ball to at least be above 3 feet. So I'm going to draw in where the net will be. And I know that this length is going to be 3 feet because I need that ball to go above that net. Now we don't know how high this ball is. And that's the whole point of this problem. So I'm going to label this guy X because I'm going to eventually want to find out how high the ball needs to be. Now, here's where we got to think for a second, okay? This is where the net is, right? This is my side view. This is the net. This is where the ball is going to land. I need to find out what this side length is, and I think we have already figured out what that side length is. I want you to look back to this original diagram we were working with. This is the net. Think about looking at it from the side. This is where the net is. That's where the ball needs to land. This distance that we found is actually the bottom distance of this triangle here that ends up representing this side here. And you have to kind of use your brain and think about it and kind of visualize the space, right? If this is the bird's eye view on this diagram here, this distance from the net to where the ball lands, from the side view ends up being this bottom part of the triangle. And the same thing can be said for this distance here of 42.77. That part here is this length right here on the original diagram. And it's going to be this bottom spot on this triangle here. Okay, so again, we have two right triangles. They are similar triangles from AA similarity. They have right angles in common. They share this blue angle down here. we can set up side ratios and we can now solve for x. So if you want to solve this for x, I'm going to scoot this over. We could write 3 over 23.03 equals, right? I did this length over this length. Now I'm going to do this whole length here of x over, now be careful, right? It's not going to be just 42.77. We have to add in the whole length for this whole side, and that would be 65.8 feet. Again, all you guys got to do is cross multiply and solve, and you'll get your value for x. Now again, I have more faith in you that you can do this on your own. I'm not going to actually solve for it. I know that you can do that on your own. So I want you just to take a step back to look and see the whole problem that we worked out. Okay, all we did was create different similar triangles so that we could use it to solve these different side lengths. And now we know how high the ball needs to be in order to clear the 3-foot net. And now you can finish up this problem and solve the rest of problem 70 and 71. All right, guys, I'll see you next time.